After watching this video, you will be able to go swiftly through any type of circuit. Stay tuned. Hello everybody and welcome to a new video. In this video, we will be introducing a very important topic, which is circuits in parallel and circuits in series. Okay, so this is one of the most important topics in this chapter, and lots of questions in the exam are from this lesson. So let us get started right away. Okay, we learned before that there's something called a resistor, and a resistor is something that can control or change the resistance inside a circuit. Now, these resistors can be lined up in two main ways, either parallel or in series. The total current, the total potential difference, and total resistance depends on whether the circuit is in parallel or in series. So the lineup of the resistors is very important in the total resistance of this circuit, in the total current, in the total potential difference. So lining up these resistors in parallel or series changes everything. Okay, so let us see what the difference between a circuit in parallel and series is. Now, this is how they look. This is a series circuit. Actually, it looks just like a simple circuit where we have a battery and we have three resistors, right? Okay, a battery here, and here we have resistors. Let's call this, say, R1, this is R2, this is R3, etc. Okay, and this is a cell, or what we called a battery. Now, let's see what's the difference between it and a circuit in parallel. In general, they look alike, but if we look a little bit more deeper, there's a very important difference between them, is that in a series circuit, the resistors are all lined up and connected on the same wire. So they start from this point, and the wire is connected through the three resistors inside this circuit. But if we look at a parallel circuit, every resistor is connected on a different wire. Actually, it's like we have three simple circuits. Like we can say this is one circuit. Okay, we can say this battery and this resistor, forget about this resistor right here, it's like another circuit, and it's like we have another third circuit. So it's like three separate circuits connected to each other. We call it a parallel circuit. Okay, another main difference is the potential difference. Let's imagine that this battery had a certain potential difference, say 40 volts. The potential difference here is going to be, say, 20 volts. Here it's going to be, say, 10 volts. And here it's going to be 10 volts. It depends on the value of the resistance, okay? But the potential difference, the total potential difference, will be the potential difference in the first resistor and the second resistor and the third resistor. So 10, 10, and 20 is equal to 40. But in a circuit in parallel, the potential difference is the same throughout the whole circuit. So if this battery gives out 40 volts, each one of these resistors will take 40 volts. So it is not separated. The potential difference is the same throughout the whole circuit, while in a series circuit, the potential difference, you must add up the potential difference passing through all the resistors to get the total potential difference in that circuit. Okay? Another very important and main difference is the total current. So in a series circuit, the current passing through all the resistors is the same. Actually, we can imagine it. We know that the electrons are moving from the negative side to the positive side, or whatever. So electrons are passing through this resistor. Do they have anywhere else to go? No. So they have to go through the same wire, and they go through this resistor. And since they don't have anywhere else to go, so as you can see, the electrons or the current is the same throughout the circuit. So the current here is the same as the current here, is the same as the current here. But in a parallel circuit, it's a little bit different. Let's say that the electrons or the current is moving from this side. When it reaches this point, it has two ways to go. Some of the current passes in this direction, and some of it continues in this direction. And some of it also separates here again. And finally, some of it goes here. After that, they all get reunited, and they all go back to the same battery. So they get reunited right here, and they go through the battery. So the current right here is different from the current here and it's different from the current here, and it's different from this current, depending on the resistance of each of these resistors. Okay, so now we looked at the shape, the differences in the shape, we looked at the potential difference, and we looked at the current. Okay, finally, let's look at the total resistance of these circuits. In a series circuits, it's very simple. If I was told to replace this resistance, which is R1, and this resistance, which is R2, and this resistance, which is R3, with one resistor, I would get a resistor that has a value of the summation of these three resistors, R1 and R2 and R3. So I would just simply add the resistances together to get a total resistance. So say this had a resistance of 5, this had a resistance of 5, this had a resistance of, let's say, also 5. I can throw these three away and get one resistor with a 15 ohm resistance and replace it with all these three. But in a parallel circuit, it's a little bit different. We are going to use this equation to find the total resistance. So if this is R1, this is R2, and this is R3, and I was told to replace these three resistors with one resistor, the total resistance is going to be, or 1 over the total resistance is going to be 1 over R1 plus 1 over R2 plus 1 over R3. So after we add these three numbers together, we must flip them to get RT because we want RT. Okay? Now, maybe things are not that clear, but now we will be solving problems and it will make things a lot more clear. Let's look at this important note. If one of the resistors here in a series circuit is burned, let's say the current is passing through this resistor and this resistor is burned. It's like what happened here is like we cut the line. So there's no more place for the electrons to flow through the wire. So this is a downside of a series circuit. In a series circuit, if one of the resistors goes down, the whole circuit goes down. But on the other hand, it uses less energy because we knew that the potential difference gets divided on these three resistors. But in a parallel circuit, if one of the resistors burns, the other two won't stop or won't be affected because, as we said, it's like we have three circuits. This is one circuit, this is the second, this is the third, and everyone is connected to a wire. So let's say this resistance is burned, the current just can continue its way to the other two resistors. Okay? But on the other hand, it uses more energy because we said that the potential difference given from this battery will be given the same value for this resistance and for this resistor and for this resistor. Okay? I hope that makes everything clear. Now, the final point in circuits in parallel and series is that we learned before that we have a device called a voltmeter and we have a device called an ammeter. These devices are supposed to be connected in a certain way in these circuits. We can see that an ammeter must be connected in series. Ammeters are always connected in series in circuits. That means it is connected directly to the main wire or at the point we want to find the current at. But for a voltmeter, look at a voltmeter. For a voltmeter, it must be connected in parallel. That means that I must take two separate wires and connect them before and after the point I want to read the resistance at. So if I'm reading the resistance at R2, look, I will take a wire from this side here, and I'll take a wire from the other side, and then I can read the resistance for R2. Say, for example, let's try drawing a voltmeter to read the resistance at R1. It is very simple. I will take a wire from here and I will connect the voltmeter like this and I will close the wire right here. Another example, if I want the resistance at this battery, I will connect a voltmeter at the same method in parallel. I hope that makes things clear for these types of circuits. Now, let's sum up what we said in this video in this very simple table. We can say for series circuits, how it's drawn that all resistors are lined up and connected at the same wire. But for parallel circuits, every resistor is connected on a different wire, okay? The total potential difference for a series circuit is the potential difference of the first resistor and then the second resistor and then the third resistor, but the potential difference is the same for parallel circuits. As for the current is the same in series circuits, but it is separated and it's not the same in a parallel circuit. The total current will be equal to the current in the first resistor and in the second resistor and in the third resistor. As for the resistance in a series circuit can be found, or we can find something called the equivalent resistance by just adding up the values of the resistors. But for a parallel circuit, we will have to use this simple equation: 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Finally, if one of the resistors burns in a series circuit, it will stop and it uses less energy. But for a parallel circuit, if one of the resistors stops, there's still way for the current to pass through and the other two resistors will stay on, and it uses in general more energy. Ammeters are connected in series, but voltmeters are connected in parallel. I hope that makes things clear. You will need to watch the videos coming up next to get a more detailed idea about these parallel and series circuits. So we will be solving many problems with real nice ideas. We can face them in real life. We can face them in the exam. So stay tuned in the next video. See you then.